Okay. And then okay. Do I need to go back and review anything, or my? Okay. Okay. So we lost the record on one of the computers here real quick. So I just started the record on my side here. Okay. So so this slide's animated to show you the data flow and how it flows through the program. Your data doesn't necessarily need to be written to or read from a memory space like you would normally do in a classic programming language, where you declare it and set your variable as A. Well, in this case, A is a control, and I've got that control wired to other nodes in the program. So if I can find my mouse here, A is connected to a node here, and this is a multiplication function. It's also wired to another multiplication function down here at the bottom. So the question that comes up is, which of these two multiplication functions is going to execute first? And my first answer is, does it really matter which one executes first? And if it does, you may need to control that. However, in this instance, once A provides its value, both nodes have a value. The other node is a constant, so it already has that value in the other node. Either one of these multiplication functions can execute at the same time if you're running a multiple core system, or they can happen milliseconds apart sequentially, or they could be effectively in parallel. So in this case, by letting the compiler decide how it's going to execute the system, you can actually speed up the execution by not defining which one happens first. Because if, like in this system, I think it's a quad core, I think I've got 16 different hyperthreads that could be potentially used for this program. This is probably happening in parallel on my computer if I execute this code. However, a simpler system that may not have all those hyper-threaded nodes in the core, or that many cores in the system, it may have to happen sequentially. So by allowing this to be dynamic and letting the compiler decide at the runtime which one happens and in what sequence, you can potentially improve the efficiency of your program. Now, as you progress through the system, this node all the way down here can't execute until it has both of its inputs. One of them, as you trace the wire, is basically set by the control at the very beginning. The other one, there's a function, there's a function, there's a function, there's a function. The other side, there's a function. So there's a lot of steps to get to this node down here. It will not execute until all of its input nodes have values, and then it'll provide an output value for that node. Now, this is a simple subtraction function. If you had a very complex subroutine in there that needed two inputs to execute, it may take time for that node to execute in that case. If that happened to be a piece of vision code that was sitting right there, that may take real time, as in seconds. And I've actually seen some systems, depending on the complexity, take minutes to execute. Now, you don't want to lock your program if that's the case. And so that's where, if you can segment your code down or allow more parallel execution in your code, you can actually, a lot of times, get better execution time with that. Now, that is a deviation from your standard method of programming. Most people want to see their program execute step 1, step 2, step 3 in a lockstep sequential method, much like most of your classic programming languages. They will start at the top, go to the bottom. You may skip around to line 1000 where there's some subroutine and come back to line 10 to finish your program, but you're effectively running the program one line at a time from top to bottom. Now, as you get into object-oriented code, as you progress, you're starting to bridge the gap from that sequential execution to a little bit more parallel capable code. And there's a lot of the languages can be written so that they can be run in parallel. However, the code to make that happen is very complex and very, very intensive. Labview does it by default. That's built into the back end of the engine itself. And this does run very well across a ton of different platforms. One of the things that if you need to see the execution, you have the option, and it's shown highlight here on the top of the screen here, to turn on the highlight execution. You also have an option here next to it that retains the wire values, that allows you to do some probing into it when it's either done running or even as it's running here. If I were to drop a probe on this, and I'll show this live execution here, or some code running live in a little bit of how you drop the probes. But if it's in a run mode where it's actively going, you can click on the wire and it's going to automatically drop a probe for you. If you're in the development system and it's not actively running, you can right-click it. In that right-click menu, there's an option to drop a probe there as well. I'll talk a little bit more about that for troubleshooting techniques in just a few minutes. Any questions on any of this that I've covered so far, guys? Go for it. Yes. So the question that I'm going to repeat it for the webcast here. So what you're asking is, in most IDEs, you have the ability to go into kind of the back end and change some more of the back end code that are, and I'm assuming you're talking about like these subroutines, like this multiplication function. If you wanted to change that function to something else or to modify it slightly of how it behaves, the short answer is yes. Now, there are functions in Labview that you can't change, but even in most programming languages, you're going to get down to some primitive that you can't actually modify, but you could modify it after the function. And that would be like, in this case, these multiplication, these basic addition, subtraction, multiplication, division. You can't modify these specifically, but you can modify anything before and after the wires. And so you can modify it on the fly effectively as it's being, not while it's running, obviously, but you can modify how the wires are being handled, and that effectively modifies the way it executes there. Now, to go beyond kind of that basic level that we're showing on the screen right now, almost all the sub-VIs that you're going to be provided, you can go into and modify. Now, the ones that are in the WPI library, some of you won't be able to, but the ones you can, I would encourage you not to. If you do want to make a custom version of it, bring it up, save as, and give it your own name and modify your version of it. Because that way, if you ever need to go back, you don't have to reinstall the WPI library to get back the original version. And the same goes with the examples I'll show you here in a minute. And I think I'll go into what you're talking about a little bit here when I show the FRC code in just a moment. So kind of coming back to it, the answer is yes, until you get down to a certain level, similar to like your primitives and some of the other languages. There's a level where it is source code, or it is in the source code effectively, and you can't modify it beyond that. But if you do, like if you needed to add an average function to this, you can create an averaging function and put it right after the multiplication if you wanted to modify the way the multiplication was being handled. You can also do that almost manually. There's a coding node that you can drop and actually do your function in text-based language as well. So you do have that level. So you can have two inputs, and you want to define some crazy quadratic, let me even pronounce it right, equation or polynomial to get to where you're wanting to go, and you've got all the inputs and the variables and such, you can do that. And sometimes that complex math is actually easier in a text-based form than trying to do it graphically. And I understand that. And National Instruments does, and they've actually provided a method. I think I have a slide for that in here. Yeah, right there. I just skipped over. So this is obviously a relatively complex algorithm or formula they're using in here. But they have 4 or 3 variables at the front and 2 output variables at the end. And they've created an equation, and there's even an then, excuse me? Yeah. And there's some pretty good documentation on this node that's out there, and there's some pretty good examples in Labview itself. Okay. The question is, what are some things that a student can do to practice programming skills if they don't have access to a RoboRio or their actual robot? Maybe over the weekend, or maybe as we're getting ready to have is a winter ice storm that gets ready to hit us. What can we do tomorrow or now we don't have a day at school? What can I do in practice? There's actually a robot simulator in here, and I'm going to demo that for you here in just a few minutes. Yes, I'm getting some surprise looks. There is a robot simulator. There's also, if you're using the Java or the C++ platforms, there is another simulator as well. That one you have some more capabilities with, but the default Labview simulator is powerful enough and flexible enough to do everything but your own robot. And by what I mean by that is you have to use the default robots that they have in the code, but they're pretty well documented. You can actually do quite a bit with them, and I'll show those to you in just a few minutes. Any other questions? Yes. Uh-huh. There are some ways that you can use your Java, or so the question is if someone on the team is used to or familiar with another programming language, and the two that he specifically called out was Java and C++. Those actually also are the other two languages that are easily done with the RoboRio, but it could also extend into some other languages as well. Into like maybe you've got somebody on your team that's very familiar with the Raspberry Pi, or maybe there's an older gentleman that uses a lot of other languages like MATLAB and such for work. The short answer is yes. And there's on NI's website, if you do some to use X code in my Labview, if you do a search for using C++ with Labview or using Java with Labview, there are some pretty good tutorials on how to do that. It is not, let me put it this way, it's not actively supported by the FRC FIRST community directly, but I think if you ask some questions in Chief Delphi, and definitely if you ask questions on the NI forums, like I said, there's some tutorials on how to do that. There are some limitations, and you can't usually just drag and drop your code and make it just work on the fly. You do have to put kind of a wrapper around it of some degree to make it work. But the short answer is yes. There's actually a couple of teams I know that use the GIMP and the Git, I think it was Git, the alternate vision application, but used Labview on their robot, and they got the two to talk together very, very efficiently. In fact, some of them were using a standard Android phone to do all their vision processing, and was passing targeting data back to the robot to actually do the targeting for a gimbal that they had to fire on the robot. There is they've got an updated one for, so I've got one of the students here that said that for the FTC, there's a Java APK that allows you to download and do some of the vision application, build it and deploy it that you can use through Java. And that is one of the changes for the 2017 FRC season, is they are moving away from the National Instruments Vision Development Suite. It is still supported, and it's still available to be used. So those of you that are like myself, that is very into Labview and likes to use everything on the Labview side, it is still you still have it, you're still allowed to use it. But because of the direction the community as a whole that they're observing has gone, there's an alternative out there that does not have to be actively directly installed on your RoboRio to be able to be used. It can also be, it's a lighter execution platform. So if you've got a smaller processor, whether it be a cell phone or a small secondary computer like a Kangaroo that you're using, it can also be easier run on those lighter weight CPUs. And again, check out the WPI library, the webpage that I keep referencing back to. There's a really good overview on what they did and why, and then also how to download it and how to experiment with it. However, if you guys have questions on the Labview side of things, I will still be here, and I will probably I still do. I use the Labview Vision Development Module professionally for my customers, as well as I encourage our team to use it as well, mostly because I'm here to support it. But we do have somebody on the team that has been using the FTC version of things. Yes. It is in the 2017 already, yes. So the question is, can I develop the script using the grip and the Java development side of things and run it directly in Labview? I'm going to hedge my answer here slightly, and I apologize for that. I think the answer to your question is I think so. You could do that. But my secondary side of that answer is I'm not sure why you'd want to. And the reason I'm going to say that is because if you develop the sequence in the Java, you can do the same thing in the NI Vision Builder, and actually develop the exact same sequence on the Labview side natively. And now the native code can be natively compiled and directly installed if you're already using Labview. So now your compiler efficiencies, and we were talking about earlier with the parallel code execution, Vision is one of those things that is primed for parallel code execution. So where the Java side of it is going to run sequentially, no matter what you do, pretty much no matter what you do. You could probably break it out and run various nodes to get it to be more parallel, but it's still going to be based on a sequential programming language. So that would be one of the things I'd encourage you. Great tool, use it to develop, especially do your initial testing. But if you're using Labview as your base development language, I'd encourage you then to look at the Vision Builder and try to build it there, because then the code snippet that comes out of the Vision Builder is Labview, and you can start playing with the execution time, the execution speed, and you can start playing with more parallel execution options. Yeah. Yes, so is that your question? Okay, so to follow up on what we were talking about previously is he's noticed that the grip application has the ability to talk using the network tables just like Labview does. And what that is actually ends up doing is if it's installed and is running on your Roggow, it is a secondary process, secondary thread, effectively, that's running beside Labview, and the two threads, the Labview default code, or I said default code, your robot code, and the grip application actually talk using the network nodes. So what they've got is it's actually talking to Labview through the network tables, but one of the advantages that actually can give you is that if you want to run it on your driver station, you can now run your vision code easier on the driver station side and let it talk down to your robot or across the same way as your driver station does down to the robot. And that way you can separate the Roggow and your vision code a little bit better. You can do the same thing with Labview as well, but it's not as well documented. And I'm going to be the first one to admit that. So does that answer your? Yeah. Yep. But you can run both sides, both applications, the Labview vision or this new system, either way on your driver station side as well.
So if the team right now, they don't have access to a Labview expert, would you recommend them, and they want to go off in provision for using grip or use Labview vision?
The question is, they don't have a Labview expert like myself potentially available, or someone that understands the Labview vision side of things. Which route would I recommend they go? A lot of that's actually come down to what your developer's experience level is with vision. The Labview version of all this stuff is a little more fiddly. It's not quite as of a clean interface to develop your algorithm from start to finish. So if you are not, if you're pressed for time and you're all based on one developer, I think maybe the new Java development system might be the way to go to get into it. However, if you've gotten to the point where one of the things that can happen is you're acquiring all the images on your robot, transmitting to the driver station for processing, and now the driver station is transmitting back the robot the commands. You're starting to have jitter issues. You're starting to have network issues. It may be time to start trying to separate portions of that between the two systems. So maybe doing some you've got the Roggow, if it's not at 100% on the CPU usage, you've got CPU cycles that can be dedicated to vision. And so now either dividing between the two systems or looking more towards the vision, the Labview vision application to help offset that load. Because you can effectively get it to all run 100% on the Roggow as well in both instances. So does that kind of answer your question? Okay. Any other questions? It doesn't have to be vision related. Yes. Yes, and that is actually one of the new things this year is they have gone to, they've changed their licensing on all the stuff that is deployed through the WPI library side, and is now all open source. And so it can be used not just for the FRC applications, but also outside of FRC as well. They have a GitHub repository that you can download all of that stuff on. And if you look at this WPI link, I've got to escape just a second because it's on that right here. So if you come and look at the WPI 2017 control system, there's a link in here about the vision stuff, as well as all of this that's available to you for free to download. I'm sorry, I don't think I repeated that question that time. The question was, is it free, the vision that we're talking about, the software, is it freely available, or is it available for download somewhere? And so that's where that answer came from. Apologize, missed that one. Any other questions? Okay, so I'm going to change my screen configuration here just a minute so that I am not quite so far away from, because I'm not so hard to see the projector on this. Okay, now I apologize if you're going to see some of the screens for the video chat. I'm going to minimize those because I think Ray and Harold are really the two that are on here with me. So, Harold, if you say something or if you send a chat, I may not see it right now. I apologize. All right, let's get this. Oh, it undid. All right, I apologize for the format change on the screen, especially during mid-broadcast. I hope that comes through okay. All right, so if you've gone through and got all the Labview installation completed, I'm running Windows 10, but you can also do a search for whatever version of Windows is, and I hope you know how to find that. You can do the all programs. Mine's in the most used link down here. If I scroll down here to the N section, there should be a folder for National Instruments, as well as the NI Labview. When you launch that, it's going to launch a screen that looks something very similar to this. And because I've already installed the overlay, or the 2017 FRC updater, this is what my dashboard, or the drop screen it looks like for Labview now. You notice it does look different from when I showed it to you earlier. Cannot see my screen. Okay, just a moment. Stop the share. Share the screen again. Desktop. Can you see it now? Okay, I apologize for that. Okay, so to get to the screen, let me close it and I'll show that to you again real quick. I'm using Windows 10, and so mine may look slightly different than yours. I like to usually do a search, just simply search for it. However, you can click the all programs. You can see it here in my most used. If you scroll down to the end section, there'll be a National Instruments folder, and here is the Labview 2016. When you get it launched, it's going to look something along these lines. You're going to have, this is, of course, with the Labview, the National FRC 2017 updater installed. You should get this screen. To start with, the Getting Started screen actually has a lot of good information for you initially. Usually from your day-to-day, so you're probably going to be using this screen here, the projects link, to either create a new project for the robot, maybe do a new dashboard project for your driver station. Also, you'll notice I've got, these are the most recent projects that I've opened down here underneath the open section. From there, you've got some tutorials. I encourage you guys to look at these tutorials maybe this weekend, or maybe this week for those that are in this area with the ice storm that we've got coming. But these have got some really good information about setting up the Robo Rio, setting up an access camera. You've got some editing team code. You've got integrating examples into the robot code, which is a good one. Integrating vision into robot code. So these are all some really good topics that can help you get started in some of these more complex tasks. The next step is utilities. If you have not, if you're a brand new team and have never imaged your RoboRio, you will need this imaging tool that's right here. If you've never set up an access camera, you'll probably end up using this. There's some other tools in here that you can utilize. If you have the team radio and that was in your kit of parts, it should already be configured. However, if you need to configure or if you're having problems with that radio, you'll need to go to the WPI library and find the Getting Started with Your Radio section, because there is the WPI Team Forge site that you can actually get the radio updater. And that will be required to have been done, either use the radio from your kit of parts, or you'll have to do the updater the first time you get to your first regional. The radios do have a new version of firmware if you're using it from last year, and they may not actually even talk to the driver station this go around if it's not updated properly. So please look at that, the WPI library, and get that updated if you have not done so already. For those of you that are here today with me live, we'll either check your radio if you've got it with you, or I'll make sure you guys have the tool before you leave so that you can do it when you get back to your back to where your radios are located. To support, these can be a really good source. The discussion forums, you can find some FRC examples. I'm going to show you that example finder here in just a few minutes. Another source that is for the build season only is this phone number. This phone number is actually for National Instruments Direct, and they've got a support line that can help you through some of your problems. So know that that is available to you if you do need it. I believe the phone number is only active until like 7 p.m. at night. So if you get too late or if it's on the weekends, it may not actually, it may not go through for you. However, know that it is available for you as well. All right. So before we get into the example finder, and before we get into other things, I want to show you how you'd set up a new project. So you've never done Labview before, and you actually want to do your very first project. You're going to come here to the New section, for the Projects tab on the left. Under New, there's the FRC RoboRio project. You're going to click on that. You're going to get this Create New FRC Robot page. It's going to pop up. The first thing you've got here is the project name. The very first thing I need you to do, give it a real name. Don't just click OK and use the default name, because you're probably going to end up with 5 or 6 of these. And yes, they'll probably auto-increment the number beside them or something like that. But when it comes down to wire and you really need to go back to that last version that you had that really perfect sensor working, and you've got 15 different robot codes that you have no idea what it's for, it becomes a headache to figure out what you had. So even if this is a test project, give it a name. I'll use the 2017 probably, just so I know what season it came from. But for this demo today, this is my 5th demo that I've played with, so I'm going to name this demo 5. And since this is my demo robot that I'm going to be doing this on, which I will show this to you in a picture in a little while, it is a very, very simple robot. I only have a light connected to it and the robo radio, or the robot radio, and that's it. Like I said, I'll show a picture of it to you guys later so you have an idea. I'm going to put my initials after this one so I know that it's the demo 5 that I did live, but also my robot. You guys may not have more than one robot, and that's okay. But if you're playing with a simulator, you may put simulator and your name beside it, or simulator and what your goal was that you're trying to do with this project. Make it meaningful. Make the name meaningful for you. When you're getting close to the final code for your robot, you may name your robot. And so maybe this code is going to be 2017 and the name of your robot for that season. And you may put OKC regionals, or you may put whatever the regional that you're getting ready to attend, just so that you know that that's the code that you used for that regional. Any of those types of options are great. Okay, the other thing is you want to keep in mind is this location down here, the project folder. This is where it's going to save all of your code to when it creates this project. The next thing is your team number. And I'm going to use our local team number here, so 2341 for myself. use your team number because you've probably configured your robot, your radio, to your team number already. So you need to use your team number or the team number that was used for your radio, or at least your RoboRio. Otherwise, they have a difficulty connecting to each other. All right, so the next step is the arcade drive with robot arm, and the Mecham drive with arm. I believe there's actually an example, and the simulator works with all 4 of these examples. One of the ones I do want to point out is this arcade drive command and control. This is a slightly different software architecture than what I'm going to show you today. If you're interested in a little more advanced, slightly different way of programming a robot, it's kind of using a more cutting edge programming technique, this command and control one's really cool one to experiment with. There's a really good white paper on National Instruments about the command and control in general, and there's an example and a tutorial on the ni.com/FRC page that goes to this command and control example as well. Right now, I'm going to select arcade drive with ARM because I want to show that to you in the simulator. This will give you an example of what's the output's going to be, and you're going to click finish. Should take just a minute to actually configure the project, and when it's done, it's going to pop up a project window that looks something like this. One of the habits I've gotten myself into is that when it comes up, I go ahead and click Save All once, just to make sure that once it's been generated, I've saved it once for myself. From here, though, we've got everything we need to actually start programming a robot. And before I do any changes, I'll show you guys the robot simulator. So the default code has a few sections. You've got your robot main. Under the team code, you've got most of the VIs that you'll be working with throughout the season right here. The other portion you'll be working with is down here in the build specifications. There is the build specification to be able to deploy your code to your RoboRio and have it run every time you restart your system. But back to that simulator. So I'm going to open up the robot main. And for the first time, at least, this will take just a second or two. Now, robot main, this looks a lot like my PowerPoint presentation. In fact, I took a screenshot from one of these that I created just like this. But you've got the robot main up. If I either go up here to Window and show block diagram, or the shortcut that shows me is Control-E, and that's what I will be using most of the time is Control-E, switches to the block diagram. So here's the same screen that we were shown in the screenshot earlier for the block diagram itself. Now, for that simulator, if you come down here to the bottom and you right-click down here in this window down at the bottom, and you come down to My Computer, this is going to switch it to run on the simulator versus the RoboRio. And what I'm going to do is I'm going to run this on the simulator first, and then I can actually actively deploy this to my RoboRio that's sitting here next to me as well. Okay, once my little pinwheel goes away, I will start this, and you will see the simulator pop up. All right. Okay, so the pinwheel has stopped. I'm going to come up here to the top, the run arrow, and click run. The simulator by default pops up. Now, what does it take to actually run a real robot? We need our driver station. So I'm going to come over here to my driver station and launch the driver station. I need to tell it yes to allow it to change computer settings. Now, I don't have my, hang on, get this to come back. Try this one more time. Yes. It still doesn't want to launch the rest of my driver station. However, this is enough to show what we're trying to show right now. If you notice, I have communications, I have a robot code, and I have joysticks. Now, my joystick is one of the Logitech controllers that we've got in one of the past year's kits. I'm going to expand this to mostly full screen so you guys can see things happening. First thing I've got to do, though, is just like a normal robot, is enable. I'm full screen here. Now, on the joystick, I'm just moving it forward and backwards and left. Oh, that was right, and now back to left. Now, notice my robot is moving with me as we go here. I can enable the zoom function so I can see this a little bit better, so we can actually see what's going on. And notice I can get quite a bit of speed on this little guy. So it's not going to be perfect for what you've got in reality. However, it's got really good simulation possibilities for you to start experimenting with your autonomous code to get used to programming a robot. It's kind of hard to see, but there's actually a simulated camera on here. And so you can actually use a simulated camera. There's some simulated sensors on here that you can use as well. And what I'll encourage you to do is look at the documentation for the simulator, and you can actually program this little robot to do quite a bit. And it's going to be just like it is for your robot. And one of the things that's really good for this is if you happen to be, your build team is still in the process of, they had just tore your robot apart to change out a gear or a sprocket, and you wanted to work on that autonomous a little bit more. Like I said, it's not going to be perfect one-to-one ratio, but it is going to be a really good step in the right direction that you can actually run your code against. Now, one of the qualifiers I need to give you on this, you do need to match your, if you're going to do that with your robot code for your robot, match your driving motors, so your left and right channels, the same as that is in the default code here that runs these robots, and that'll actually help you a little bit when you try to simulate it through the simulator. If you don't have the ability to do that, or your robot's got more complex, and maybe you're using 4 channels for your drive or something along those lines, change out and go to your, just create a new project so that you can be working with or experiment with the autonomous functions and then copy it across to your main robot project. All right, so now we're done playing with the simulator for a moment. We're going to stop it just like we normally would. Have to disable it just like you normally would your normal robots. When you're done here, you can just hit the close button on the simulator itself. It's going to close the simulator and auto stop your code. Now, one of the things I'm going to talk to you, or that I want you to do when you're running these projects and doing testing, is if you use the run button when you live deploy to your code, to your robot, come down here and hit the finish button. Try not to use the stop button here at the top. And the reason I tell you that is because sometimes if you do it enough times in a row, you can actually start getting errors on your RoboRio. And to clear those errors, you have to actually do a power reset on them to get those errors cleared out. Yes? Yes, and so the question is could that be the reason why we were getting a lot of errors in our code last year? And that I'm not going to say that was the reason, but it's a likely cause for the reason, especially if you were doing it and when you started you got no errors, and by the end of your programming session you had tons of errors. Chances are that's probably what was going on. If you continually use that stop button, like I said, it doesn't actually hurt anything, except it starts to throw some really strange errors that are really, really difficult to troubleshoot. In fact, in many cases have no direct answer because everything's normally correct until you start using the stop button. So use that finish button down at the bottom, and what it does is it closes out all the memory references to all of your devices correctly at the end of it. So one of the things that can actually start happening is you start to lose functionality. Maybe you lose your SPI port, or maybe you lose your CAN port, or suddenly motor controllers aren't working, or it can be anything. It can be random, and it can be very frustrating to troubleshoot, especially when you do a power reset and it goes away. So just use this finish button if you are running the code live with the run button. Now, if you're deploying it, you don't have to worry about that as much. It is a good test to go ahead and restart your program, your software, at least the RoboRio with a power reset at least once, just to make sure that your code is there and it's live, because that's what's going to happen when you get out to the competition field. So from there, the other sections of code that we're going to touch on here is going to be your begin VI, your finish VI, and then I'll touch on the autonomous and the teleop here. If you need to modify something that's hardware related, chances are you're going to need to come to the begin to either set it up, to configure it, or to modify it. So again, I'm going to close the main because I don't need that open right now. I didn't make changes, but I'm still actually running under simulator. Switch back from the simulator. You'd right click down here in this white box and change to target. So it's going to give me the pinwheel here for just a second. And I'm switched back to target now. Okay. So I'm going to close it. It's probably still going to tell me to save. To save all. All right. So now on my begin VI, Control E to go to the block diagram. And here's the block diagram. Here is the default code for the motor controllers. You've also got canned code here for the joystick 0. If you need to make a change, this is what it would be for the, like if you're going to change up your left and right drive motors. Maybe when you wired it up, one went forward and the other one was correct. So you come in here and you can find which one that is and either just invert the individual channel or change the channels if you need to. This is also a really good example of if you have something that's spinning or moving that could cause injury, if it was activated or moved at the wrong time, this safety config, all of the different modules have the option for a safety config. Use it when you need it or when you think it could cause damage or hurt, or if like somebody need to hit an e-stop or an emergency stop, if it's something that should stop when that button's pushed, you need to add the safety configuration in there. All right, one of the things, if you add it here in the begin, you need to make sure you open up the finish and close it in the finish. So the same thing, you've got, you're creating, initializing your motors, you're closing them out and finishing the task down here. You've got your joystick. You've initialized the joystick. You've closed it out. Always, always follow that pattern. If you add something, come to the begin and add it. Immediately go to the finish and close it out. That way you don't forget. Another thing is, these names can get complex, especially if you're making them real. It's difficult sometimes to always type them exactly the same, including all the exact same spaces, before and after and during. An easy way to make sure they're perfect is simply drag and drop it to the other screen. That will prevent misspelling and any of those issues where you might end up in this some place where you need it and you can't find it. You can also, if you're in a screen, you need another copy of it. If you hold down Control and drag, it will create a duplicate copy of it. For right now, I don't need these things, so I'm going to delete them back out. But that is your begin and your finish. Remember, start at the begin, create it, initialize it, configure it, and then come to the finish and close it out. Okay, another keyboard shortcut that I use all the time and I've used and I didn't even think about it is Control W, and that closes the window that you have open currently. I made a slight change because I created something and deleted it, so saving it. The same thing, Control E to the front panel, and Control W to close it, and save all. Right, now I'm going to show you the teleop. Okay, on the teleop, we have controls, which are these objects over here, and we've got some indicators. They're over here on the right. This slider control, this can actually be a control or indicator. This is an indicator because it doesn't have the little, there's a slide control that goes with it when it's a control usually. However, notice that your controls can be numeric. They can be Boolean for true and false. They can be named numerics, which is along the lines of what this autonomous style is down here. And then you've got some that you can't change, which are still controls, but these are references for the software side of things. Okay, Control E to go to the block diagram. And this is where most of your program is going to probably take place for this season. Hopefully, your autonomous is going to be as complex or maybe bigger and longer because you're doing lots of steps and lots of sequences. But I'll show that to you in just a second as well. So remember, we had those motors configured in the begin. That's where we're getting the reference. We're calling it from where we saved it. Now we're going to do the drive. We're going to get that information for the drive from our joystick. So we get the values, and again, from that reference. We use an array function. There's some pretty decent documentation. And one of the places, if you do Control H for the help menu, it should pop up a little screen like this. If you mouse over a function, it gives you details about that sub-VI or that function. Now, earlier, the question that we had about can I modify more in depth than just what's on the surface? If I double-click this sub-VI, I now have another sub-panel, right? A sub-VI, the front panel. I can do Control E and look, here is my joystick default function for getting values. You can modify this. Again, save it, make it your own, and then modify your saved version. But the short answer is yes, you can modify. I can even get down into some pretty deep levels in here. There is a DLL code reference, or in this case, a network communication reference that you can't modify beyond this point. However, a lot of stuff could be gotten into and modified. Just know that if you modify this stuff too much, if it's from the WPI library, if you have problems during competition, the control technician or the control people that can help you Sometimes it'll be more difficult, and they're going to encourage you to go back to the defaults. So just keep that in mind. So from this joystick function, we're getting these two axes and passing them directly into the arcade drive. If you notice, we have the x-axis and the y-axis. That's coming directly from the joystick. There's nothing happening between them. Maybe you need to control the speed or control the maximum value. You could add that code right here on this, right in between here, and redirect these wires to make that happen. If you need button controls, there's an option down here to get the buttons, which is this green wire down here. Right now it's just being passed directly to the front panel, which is what this function is doing right here. But you could break this out with another array function and use the buttons from the joystick to connect or to control things in your robot. There's some really good tutorials out there. There's some really good code bases out there on Chief Delphi that you can download and look at for some resources on that. Yes. Yes. So the question is he wanted to use the POV, or it came up as the POV for his Xbox controller, and how does he program that? Your POVs are down here also. I believe it's also an array because you can have multiple ones of them. I can check this. Yeah, so it's an array function, and you come out with an element, but it's going to be an element that's instead of just a button, a Boolean button, you're going to end up with an integer value that you got to handle. Similar to what you've got here for these the double, which is these yellow lines that are coming out. You just have a value that is, the POV, is it just buttons is what they actually are? So it's probably going to be a 0 or a 1 would be my guess on that. So either 0 for false and not pressed, and 1 for pressed. And so it's made up of like a lot of little bitty buttons. What would you like to use it for? I guess is what it'll come down to. Okay, so depending on what zone it's in, you'll probably have to play with this array to find the specific location. And a place that you can actually look for that is going to be out here on the driver station. So when I come down here to my joystick control, if you notice, I've got a whole bunch of axes, a whole bunch of buttons, and even a POV. So I can start playing with, hey, I just found the POV because it's making changes. Now, which button is that specifically? You can look in, let me bring up the other part of the drive station here real quick, just a second. It should be the dashboard. Oh, that is correct. I believe I managed to misplace my dashboard earlier. Let's see what's over here. Yeah, I've misplaced my dashboard right now, so I don't have a current version of it on the system. So on the dashboard, there's a tab up here that gives you your network tables and network values, and you can actually look in that and see the values, what values each of those buttons are, because it'll be indexed out in the array function. You can see it's index array number 1 or 5 or 6 as it goes down. I know we're getting really close on time here. We'll get close on this. But so what you'd effectively use is this array function, get the index of the value that you want. So if it's like number 5 in the array, you can actually create a constant and go to number 5. And now this value out here is number 5. If you don't index the next one below it, that one's going to be number 6. So you can start at 0 and go down, manually count them, or you can do it like this if you need to as well. But then you'd use that value just like you would up here to control something. Does that give you kind of an idea of how to move forward? So it will not take this value, but what I would do then is I would probably create a case statement for it. So in this case, you've got, with it being an integer, you've got to declare what values it's going to be. So if it's just simply a 0 or a 1, what I would do is 0 in default, or 0, it's going to either be 0 or 1. It will be a number. So you can leave it 0 or default, and then 1 and ... tells it anything larger than 1, do this function. And so then I would take, if I was going to use it for this drive motor, maybe for the default value, I would leave it at just a pass-through. So we'd effectively do this with it. Let me move this up so it's out of the way for the moment. Now, if you're on my team, I'm going to encourage you to clean up these wires strongly. In fact, if I see that not cleaned up more than once or twice, I will, if I have to touch the code, I will end up doing it for you. So I'm going to do it just here for demonstration. All I'm doing is selecting and using the shift and the arrows to make it jump more than one space at a time. Then for the number 1, maybe you want it at 50% power. So I create a constant and 0.5. And that's effectively, what this is effectively doing now is if I'm not pressing it, it's being controlled default by the joystick. If I push the button or that POV value, then it's number 5. Does that make sense? Okay. Now, you might need to link a couple of these together because maybe you can't always hit perfectly the direction for that POV. And you could do some OR and some AND statements together to actually group it to where you've got maybe 3 or 4 of the POV values. If any of them are 1, then do this. And maybe the easiest answer is to add them all together. So if the answer is larger than 1 or is larger than 0, then do that function. Okay. Does that answer your question? Excellent. Okay, so I'll leave this for right now. I actually don't know what it specifically was do because I just know I'm on POV number 5, but I'm not planning on actively running this right now. Let me jump over here though to the other portion of the code that I want to show you is going to be the autonomous code. Because hopefully, I hope all the teams that view this have something for autonomous. Whether it be something as simple as to drive forward to the line and stop, do something in here. There's actually some examples, some default code in here. And I'm going to show you alternative 2 first because it's a little simpler to understand initially. All we're doing is getting our left and right drive motor. We're going to tell it, just like we would with our arcade drive, I want it to go, the x-axis is going to be negative 0.25, and the y-axis is 0.5. So basically, it's going to turn right for 1 second, and this is what's controlling the time. Then I'm going to turn left for 0.5 seconds. There's the speed for the x, the speed for the y, hold it for 0.5, and then I'm going to turn the motors off. This can be your exact code. Maybe you need to modify these numbers slightly, but this is a functional working autonomous code right here. Now in the dashboard, if I had it up, there's an option for, it's called autonomous, and it's labeled alternative 1, alternative 2. It basically has these values in it, this auto selector, and that's how you'd select this alternative 2 to run it if you wanted to run this alternative 2. The alternative 1, it's doing almost the exact same thing. However, instead of doing it with step by step in here, it is doing it through a control input. So alternative 1 has these array of robot movements. And you could effectively have this on your driver station if you needed to. You can program the same thing, your X, your Y value, and your delay, and then describe what you're doing for this function. And you can just step and increment this through step by step by step. So that first one is step 1, the second one is step 2, and you go through it and can use step through as you need. Same functionality, however, you're just programming it a little bit different. And what this one does, as long as there's still a value, it's going to index, it's not going to index, it's using this array as the index, and it steps through this one at a time until it gets to the end, and then it stops. So this is using a for loop to do the same function as alternative 2, but instead of going long like this, it's just very repetitive steps, it's doing it pretty simply, reusing the code over and over. If you want to experiment, you can do it in your turn, or you can create additional controls or additional values in here to actually have, maybe I want to be, when I'm on the right side of the field, I need a right side. If I'm on the left side, I need a left side. If I'm in the center, I have a center. So you can actually have 3 different options for your autonomous that are set up here in your autonomous code section. But that's effectively, that is autonomous code right there that's functional. And you can actually run this in the robot simulator if you needed to. The last thing I want to show you real quick is how to deploy your code to your robot. So we've got our code complete. We're ready to run it. You come down here and you've got to build it for the first one. And all I did is I right-clicked on that to get to the build menu. It's going through and it's going to say this could take several minutes. It doesn't take too terribly long here. Now I've got a RoboRio set up. I'm going to show this to you here real quick. If I can get my camera. Actually, we have a camera that should be live on the feed right now, if I'm not mistaken. I don't remember where the option's at right now. It's probably the participants. Come on. Now, I will show this to you, and you guys can tell me if you can see it or not. I can't see it on my screen. Can anybody see this on their screen right now? Can you see on a raise? He doesn't have a screen up? Okay. So let me figure out how to do this real quick, and then I'll show this to you. And then we'll do a walkthrough on the robot with the time we've got left. Okay. So on the screen here, the camera fell over. I'm sorry. For those that were watching that camera. The robot shows that it's complete. You click done on it, and then you right click on it and run it at startup. Now it's going to go through and actually deploy this out to the RoboRio. You've got to make sure that your team number matches and everything of what you were trying to with the RoboRio and everything. But this first step is trying to find the RoboRio, and I'm not actively connected to it because I can't change wireless without losing the connection. So I'm going to pull up my USB cable and connect the robot through USB to make this deploy work here. Now what this is telling me is that it could not find, it was unable to resolve the current dialogue, but it could not find the RoboRio out there. So I'm going to click cancel on this and close. I'm going to try this again because I just plugged in my USB cable. I'm going to run it at startup. It's going to go through and calculate everything. Now, this window is the same window, but now it's telling me something different. It says the target is already running a real-time startup application. Press OK to confirm that you want to abort the existing application and connect to the target from this project. So if you want to push new code, or if you're going to run your test code, you've got to click OK on this. So you click OK. Notice it's deploying, or it's actually building and deploying all the code out to the robot. And while that's building, I'll see if I can get this camera to come up here real quick. Okay, did not realize that. You guys are getting to stare at me here for a second. Okay, so this is my robot. And like I said, it is a very, very simple robot. All it has right now connected to it is the light. We've got power coming in, and I actually have a wall adapter for my RoboRio. The same thing for my radio. My network cable is going from one to the other. And then I have my light connected just like you would for your robots. It's not showing on the webcast. Okay, so just a second. Let's see if I can share this to the webcast. Is that showing up on the webcast? All right. That is. My beautiful happy face. Okay, this is going to be a little more interesting then. I think that's viewable in the participants. If you slide to the right or the left, I think it shows the participants. And I think one of those cameras is this camera that I'm showing this on. Okay, but I'll go ahead and show this on the screen too. Let me bring this up. Let me just share the video. Okay, so this is my laptop. I'm going to just lift this up and show it to you as we go here. So effectively, for those of you that didn't see it on the previous screen, this is my robot. I have the RoboRio, the radio, and a couple extra hands coming in here so I can have a hand to point things. This is my power coming, and I'm using a wall adapter. This is my USB cable I just connected to the computer so I could program it without connecting to the webcast. My network cable that goes from the network itself to, or from the RoboRio over to the radio, power adapter, and that is also a wall adapter as well. And then the only sensor or the only indicator I've got on this robot is the light. So if I come back over here, I'll try to just shift this to the side. Our deploy process is complete. So I'm going to click close. Now notice on my driver station down here, I don't have the robot code running. So what I need to do is reset the RoboRio. So I just use the reset button here on the RoboRio. You can also power cycle it if it's on your robot. Notice we are still solid on the light. The RoboRio is restarting. Give it just a moment here. And we should be live in just a second. Here in just a minute, I'm going to go back to this other camera, and I'm going to show you some other options that we've got, or some of the robots. We'll do a quick robot walkthrough with the time that we're actually a little over time at this point. All right, it still shows I don't have robot. Yep. There it went. Okay, so I just adjusted the USB cable just slightly. So my robot code is now live. I can actually run this robot. So obviously I don't have any wheels, I don't have any other servos or sensors attached to this. I'm going to come down here and click enable, and there we've got the robot light flashing just like we would normally with a regular robot. Obviously I don't have any code on here. I can control my joystick just like we would normally do, but there's nothing connected to it, so nothing's going to happen right now. However, we've deployed code. All right, I'm going to stop this, and I'm going to switch over to one of these other cameras real quick, and we're going to try to do the demo for the walkthrough. Now, for those of you that are watching the live broadcast, I believe you can bring up the other people's cameras, and this is going to be attached to one of the other cameras, that camera that we're using initially. So I'm going to angle my computer over, so hopefully you can still see it if you need it, but it's going to be a little smaller in general. All right, so let's put this robot down. Angle this around. All right. I don't think so. It's still live. Maybe not. I'm just going to try to switch cameras so I can see on here what I was. Oh. Maybe. Oh, does it still need to rejoin the meeting? There you go. Okay. Video. Here we go. Okay. So I'm going to switch the camera around so I can see what I'm pointing at as we go here. I'm going to start over here with this first robot. And so you get kind of an overview. This is one of, did you guys build this directly from the instructions, or is this, I think there's a few modifications I've seen on here. But it's basically the initial basic robot build. And what we've got here, this is the battery. You can see the cables for it sitting right here. We have the power switch, power distribution. We've got, this is a 4-motor setup, and it's a tank, or it's effectively all the wheels on each side. So all the wheels on this side are controlled by these 2 motors. All the wheels on this side are by these 2 motors. And then we've got do we need to switch cameras over there on it to make everything work right? Okay. So, well, hang on just a second. Can you switch cameras for the presenter? Okay. So we've got to modify the settings so it shows on the recorded webcast as well. Do I have to do it from here? Okay. All right. Okay, so back real quick, here's the full robot. Got the battery. There's our power switch down here. Right now it's in the off position, and I'll try to zoom in on this so you can see it. If I were to turn this on, we don't have it connected, but if you had it connected, you'd flip it down like this and you'd have power connected. turn it off, you push the red button, so the little breaker pops out again. We've got power distribution, and then of course the motors. This is set up so all the wheels on one side are controlled by these two motors, and all the wheels on this side are controlled by these two motors. Each motor has its own motor controller here. We've got them wired into the power distribution. And then the control, it looks like this one's using PWM, is set up over here on the Roggow. And this is the Roggow. We've got the network cable for the Roggow attached to the radio. We also have the small breakout for power distribution is the voltage regulation for the regulator module. And this is what you use to power your Roggow, which would be here, and your radio, which is up here. The other thing we've got is our lights, just like I had connected to mine earlier. And then the last piece that we've got here is the CAN bus, which connects our power distribution module over here. And that is a functional basic robot right there. Now, in comparison, we have last year's robot for team 2341. And I believe this is minus the lifting apparatus to do the climb. But other than that, this is the competition robot that they used. As we zoom in onto this, you'll see lots and lots of different variations. Effectively, they have very similar drive system. They've got, if you can see down in here, 2 motors, and that controls all the wheels on this side. And they've got 2 motors down here, that controls all the wheels over here. We've got the main battery. We have motor controllers mounted up on the sides over here. If we look in, if I can move some of this real quick, we've got wires. Oh, no, that's okay, we'll go through it. Okay, so flip the flap up here. We've got our power distribution board down here. We have our Roggow. It's back here in this corner. I apologize if you feel like you're upside down, because you kind of are. If you notice here, we've got a little voltage sensor that we've mounted out here, and all that's doing is telling us what the voltage is. If we go move down in here a little further, let's see, I think, okay, that's good enough. We've got some additional motors. Are you okay? It is? Okay, okay. Okay, so we've got some other motors that are back in here. Let me switch my screen again. You guys still okay? Yeah. Okay, so we've got some other motors that are back in here doing other functions. Some of them are using this is part of the winch mechanism. You've got the radio. And if we flip around back this direction, I believe this panel pops up here. We've got a sensor that's sitting out here, and I believe this is the gyro. I don't know they actually used it a whole lot last year, but it was there, and it was used for a short period of time at the very least. Right here, we've got a camera, and notice it's on a servo, so it can be moved up and down, or so you can look up and down a little bit. We've also got more motor controllers for more functions. We have a feed reel that's right here in the very front. That's how the balls were fed into the system. The shooting mechanism, they actually removed for the final competition for a couple of various reasons that they had. And that actually would have sat right up in here to fire the ball up and out this direction towards us. We've got the small motor here that runs this feeder reel. And that is the robot. Now, what does this all connect to? As I was demonstrating online, here is their driver station. And we're actually connected to this robot right next to me. And so that's my foot that you're seeing in the screen. There's a hand. If we come down here, I can tilt the camera up. And now you see me holding both cameras. Wonderful view there. But that is basically the robot. If you notice, we do have power turned on the robot. However, our lights are not flashing, which means we're not enabled right now. If I back out here just a little bit, go ahead and enable. Notice the lights are now flashing. Good practice, and we have motion for the robot. A really good practice for when you're working on your robot, especially as you're getting used to the whole system, the control systems and such, make sure that before power goes on, you warn everybody that's around the robot that power is going to be turned on. It's not necessarily dangerous, but it could be, especially if something's not wired quite right. The other side of it is, if you have the control station and those lights start to flash, hands had better be out. We always do enabling robots, and whoever's got the control of that system always looks up and makes eye contact with people that are around the robots to make sure they're aware, and hands are out of the robot. And then you go ahead and enable the robot. Using the verbal and the eye contact has prevented us from having any injuries to date to this so far. These robots are powerful. A year or two ago, we were shooting Frisbees, and we were able to effectively shoot a Frisbee half the length of a football field. If you can imagine what that would feel like in very close proximity, or how fast that wheel had, the launcher had to be spinning to get a Frisbee to go that far, you can imagine the potential danger there is in these robots. So please be careful. Use the safety techniques like we do for robot enable and power on and such. Develop your own. Use them, please. We don't want to see anybody gets hurt on this. But that is effectively the walkthrough for the robot. I'm going to step back to the computer here, and well, actually, first, does anybody here have any questions before I put down the camera? Anything? Everybody good? All right. I'm going to come back to the computer station in real quick, and I think we're pretty much done, unless there's any questions on anything else. Okay. Uh-huh. I'm going to actually take that offline for at least for the short term here. So I'm going to stop the presentation to talk to you about that. Sorry, that's the second time I've dropped that camera. But if we do a presentation on this next Tuesday, and even if we're not going to do a formal one, if we have the meeting space, we might go ahead and do a short Q&A. So we'll just see how that all works out. Either way, though, we'll go over that here in just a minute, and then I'll make sure it's on my list for if we do another broadcast that we go over those steps as well, because I'm sure other people are going to want to know that. Any other questions? Waving to the world at large for the recorded session. Yes. And he's probably going to continue to pan to show my beautiful mug as well. So hello world. All right. I think that's it for today then. Thank you very much, and you guys have a good day. How do I stop the recording? There it is.